Hello, welcome back to the series on gradients and differentiation. So in the previous few episodes we've looked at simple differentiation of functions, the product rule, the quotient rule, and what happens if we have a function that is a summation of other functions or other simple functions. In today's episode we're going to look at something called the chain rule, and what happens if you have a function like this, like y is cosine of x squared plus 2. So this doesn't fall into those other brackets. It's not a simple function. It's actually an amalgamation of two functions, a cosine and then also this, which is also acting on a separate function. It's obviously not a product and it's not a quotient. So the question is, how do we do this? Because if this was something simple, such as y equals cosine u, then this becomes a function we can do. We can do dy by du and find the answer. So the way we do this is by the chain rule, which is a substitution method and takes advantage of this. So the idea is that dy by dx could be equal to dy by dx multiplied by 1. This is obvious, so you have to bear with me, but if you multiply something by 1, it returns itself. So if we now replace this 1 with something that would be equal to 1, sort of du by du, this is still the same because du by du is equal to 1, so we're still getting the dy by dx. And because this is now multiplication, we can change the order. So this can be written as dy by du multiplied by du by dx, and this is the chain rule, and this is what allows us to do this. So if we said that u was equal to x squared plus 2, so the thing in the brackets, we can now find dy by du, so we start this over here, dy by du, so this means we're differentiating y with respect to u. So the differential of cosine u is going to be minus sine u. And we also need to know du by dx. So we're going to differentiate this with respect to x. So this is going to go to 2x. And all we have to do is multiply these two together to form dy by dx. So this is going to be 2x. I'm going to take this minus out, but it's here, sine u. So there's one side problem that we've ended up with the a u in our equation, but we can resubstitute that back in using this u here. So this is going to be minus 2x sine, and we're going to resubstitute what u was, which was x squared plus 2, and this is now our differential of dy by dx. So this is how we use the chain rule. We take what was in the bracket and we substitute that for u. We then have two equations, a y is equal to something in terms of u, and a u is something in terms of x. So we've got two different functions. We differentiate the dy with respect to u. We differentiate the du with respect to x. We multiply the two together, and if we end up with the u terms in it, we then resubstitute what we used for u back in, and we get the answer out. So, as usual, thank you for watching. Please subscribe and check out more videos in this series in the playlist, which is linked at the end of this video. And next time we will look at what happens with implicit differentiation and if we have multiple variables.